Good morning, everyone. So today, what we are going to discuss, the topic cyclotron. So what we are seeing that it is a front view of the cyclotron. So what is this? Inside this, we are having this main section view of the cyclotron, and in this cyclotron, what we are doing, we are applying perpendicular magnetic field in the perpendicular directions that we can see north pole and south pole. So particularly we will be discussing this section part of the cyclotron. So let me go to a better image. So this is how it looks like. First of all, let me discuss what is cyclotron. Cyclotron, it is a device which is used to accelerate charged particle like protons, neutrons, alpha particles, etc. We need this cyclotron particularly to accelerate these charged particles to a very high energy. Um, Now let us discuss the principle of working of cyclotron. So what is the principle? The principle says if a charged particle can be accelerated to a very high energy, so what happens? It passes through it is the charged particle, it is made to pass through an electric field. Then with the help of the magnetic field that we are applying in the perpendicular directions to the charged particles, the charged particle is forced to follow a circular path. Then following the circular path, then the charged particles comes out uh, by deflecting through the negatively charged deflecting plate, and the particle that comes out of this path, it is of very high energy. So now let us discuss the construction of the cyclotron. What is this construction of cyclotron showing us? It is showing us that it consists of two small d's that we can see d1 and d2. What are these two d1 and d2? They are half cylinders of metal, and due to their shape they are known as d's. Then we can say that these d's, they are mounted inside a vacuum chamber, between the poles of the electromagnet. We know that this cyclotron, we have seen from the front view that this cyclotron is having a magnetic field across its both sides. This magnetic field is applied perpendicular to the cyclotron. So these plates are connected to a very high energy. We can say this oscillator. What is this doing? It is providing us a very high energy, and the energy that is provided by this oscillator is of about few hundred kilowatts. And then the beam of charged particle which is to be accelerated, it is injected inside, or I can say in between the two d's here at the center, in between the two d's at the center, in the plane perpendicular to the magnetic field. Charged particles are then pulled out of these d's by using this deflecting plate. This deflecting plate, it is negatively charged, and the particle that we are using to accelerate is positively charged. So this what happens, this positively charged particle will be accelerated towards this negatively charged plate, and then it will gain a very high energy and it will be accelerated out, and through this window, I can say through this opening. And the whole this device is kept under a very high vacuum. I can say the pressure under which this device is kept is about 10 to the power minus 6 mm of mercury. Now let us discuss the working of the cyclotron. So what happens, suppose we are having a positively charged particle. So say we are having a proton. This proton enters in between the two d's here, and we know that we have kept this d1, it is a negatively charged plate. So what happens, we are having a positively charged proton here, and this d1, this plate is negatively charged. So what happens, the particle gets accelerated towards this plate D1. And as we know that when it enters plate D1, we already know that the electric field, we are having electric field in this direction, and then we are having the magnetic field in this cyclotron, which is applied perpendicular to the direction of electric field. So electric field and magnetic field, they are perpendicular to each other. So what happens when the particle enters this plate D1? What happens? It does not experience any electric field inside this plate. Why it does not experience any electric field inside this plate D1? Why? It is because of the shielding effect of this metallic D. So as we know that the magnetic field is perpendicular to the direction of electric field. So what happens, that this particle, it follows a circular path due to the magnetic field which is applied in the perpendicular direction. And at an instant when it comes out, when it is coming out of this D1 plate here, what happens, the particles feels, he experiences this plate D1 at this instant only. It experiences that D1 is positively charged, and this plate D2, he experiences this plate D2 a negatively charged plate. So what happens, that the particle, it gets accelerated towards this plate D2, and when it gets accelerated, the radius of this particle, as this particle is following circular path, so this radius of the circular path which the particle is following, it gets it gets large. The radius becomes larger when it is accelerated from plate D1 to D2. So what happens, it does, if the frequency of the applied voltage, the voltage that we are applying, if we keep this voltage at a constant value, then the electric field is reversed, and the proton, it receives a push, and finally it acquires a very high value of energy. So the frequency which we are giving to this which we are giving to maintain this energy value of this proton to a very high value, is this frequency is known as cyclotron's resonance frequency. And then what happens, when it acquires very high frequency, then the protons, as we can see, it is following a spiral path, and the accelerated proton, it is then ejected through this window, through this opening, by the deflecting voltage, and then this proton, it hits the target. Target means wherever we need to apply this very high energy photons. So now let us discuss some theory about this cyclotron. Before going to the theory, first of all, let us see, this about the cyclotron I have already discussed, and after that goes the principle of the cyclotron, and these are the steps of construction that are followed, and this is working of the cyclotron and is already discussed. So now let us work towards the theory. So now let us consider a particle of charge Q and mass m, and this particle enters a region of magnetic field B, as we already know. And when this particle when enters the magnetic field with the velocity v normal to the field, we already know that the particle enters with a velocity v, and this when the particle is entering, it is always normal to the applied magnetic field. So what happens then, that the particle follows which path? It follows circular path. So when it follows circular path, what happens? The magnetic force on this charge, the charge that we are using on this charged particle, it becomes equal to the centripetal force of this charged particle. So as we already know that the formula for magnetic force on this charged particle, it is force is equal to QVB sin theta. And theta, as we know that these velocity and magnetic field, they are in perpendicular direction, so the theta will be 90 degree. So sin 90, we already know it is 1. So what happens, QVB, it becomes, the formula becomes QVB. Why? Because sin theta is 1, and we already know the formula for centripetal force. What is it? Mass into velocity ka whole square divided by radius. So what it becomes from this formula becomes QVB. Why? Because sine theta is 1, sine 90 degrees is 1. So what happens further, this velocity gets cancelled and we get the formula for radius of the circular path, the radius that that this charged particle is going to follow, the circular path, the radius of the circular path that this charged particle is going to follow. We are having this formula. And then now if we want to find the period of revolution of this charge, what we will do, we already know that speed is equal to distance upon time. So the distance that this charged particle is following, what is this distance? This is circumference of the circle, so it will be 2 pi r. So what will be the time will be 2 pi r upon v, velocity, the circumference of the circle, and then divided by the velocity. What happens, we already know the expression for radius, so we will put this value of radius in this value for this period of revolution. So what we will get, after putting the value of r, we are getting the value of time period, and 2 pi m divided by qb. Q we already know is the charge, b is magnetic field, m is mass, and we already know this value. So now if we want to find the frequency of this revolution of this charged particle, how we will find? We already know that the frequency is 1 upon time period, it is the inverse of time. So we can directly find by inversing the value of time period. So what we get? We get the frequency as qb divided by 2 pi m. Okay, now we want to find the maximum kinetic energy that these charged particles will attain. So how we can do this? As we already know that the charged particles or the ions, they will attain maximum velocity, where they will attain maximum velocity near the periphery of the D's, So now let us consider that V naught is the maximum velocity and R naught is the maximum radius of the D's. So as we already know that the force on the charged particle is equal to the centripetal force. So this is what we have applied here. This is the centripetal force equation, and this is the force on this charged particle. As we already know that sine theta is put, sine 90 degrees put 1 here. So we get Q V naught B. So from rearranging this equation, what we get? We get the velocity, the maximum velocity that the charged particles will attain. Then as we already know that kinetic energy of the particle, what is kinetic energy of the particles formula? We already know that kinetic energy is equal to half mv naught square. So we already have the maximum value of velocity. So what we will do, we will put the value of v naught, the maximum velocity, in this equation, and we get this equation. And then after solving this equation, we get the value of maximum kinetic energy of the charged particles, which is maximum kinetic energy of the charged ions. It is equal to q square b square r naught square upon 2m. As we already know that q is the charge, b is the magnetic field, r is the maximum path, and m is the mass of the particle. Now let us discuss the uses of cyclotron. Firstly, these cyclotron, it is used to study the nuclear reactions and to find and study the nuclear structure. How? As we know that these high energy particles produced by using the cyclotron, they can be used to bombard the nuclei and to study after bombarding this nuclei, we can study the nuclear reactions, and therefore the cyclotron is used to study the nuclear reaction and also to study the nuclear structure. And then secondly, the cyclotron, it is used to produce very high energy particles. It is used to produce very high energy particles like neutrons. How these high energy particles like this, we have seen this neutron. they are produced by the bombardment of very high energy particles, है ना. So we can say that this cyclotron, it is used to produce neutrons, and also we can say that this cyclotron, it is used to produce radioactive isotopes by bombardment of this very high energy particles on the atomic nuclei. We can say that they are used to produce radioactive isotopes. Now let us discuss some limitations of the cyclotron. What are the limitations of the cyclotron? First, the electrons, we have seen that positively charged particles, they are accelerated using this cyclotron, but we have not discussed, as we know that the plates, the Ds, they are we have kept them negatively charged so that they can accelerate the positive charge. So we have used positive charge. We have not discussed the cyclotron for electrons and neutrons. Why? Because the electrons, they are not accelerated by using the cyclotron. Why? Because when we put an electron inside the cyclotron, what happens? The energy of the electron goes to a very high value. So if its energy increases, what happens to the velocity? Velocity also increases to a very high value. So what happens? As the velocity becomes very large, it becomes very difficult to point or to capture the electrons. So this is the limitation of cyclotron, that we cannot accelerate the electrons using the cyclotron. And the second limitation is neutrons being electrically neutral. As we know that neutrons, they are electrically neutral, and cyclotron, it is mainly useful for the positive particles. So hence we cannot accelerate these neutrons being electrically neutral using the cyclotron. So this is all about limitations of cyclotron, and this I can say that this is all about this topic, cyclotron. Thank you.